Okay, Learning Target 5's video. Learning Target 5, we move to solving rational equations, which is kind of a logical step because in Learning Target 1 and 2, we multiplied and divided these fractions, the rational expressions. In Learning Target 4, we added and subtracted the fractions. So Learning Target 3 required us to find those common denominators. So now we're moving to equations that have rational expressions in them, which means our answers move to x equals 5 or x equals 2. We're actually solving for an answer. So we're going to skip the warm-up problem, and the new vocabulary isn't necessarily new because we actually talked about extraneous solutions in a previous unit. They're the extra answers. They're the solutions you get when you're solving the equation, but they don't work. So remember to check your answers. The other new vocabulary, rational equation, is just what you would think it is. It's an equation that has rational expressions, has fractions. So there are two ways to solve these problems. Method 1, it involves adding the two fractions first and then cross-multiplying. This method's a little more cumbersome. It won't be so much in this problem because the denominators are 3 and 2, but once the denominators become binomials and trinomials, this method 1 gets pretty confusing. So I don't recommend it, but it is useful for work rate problems and some other problems down the road. So we'll at least keep it on the radar, but we'll focus more on method 2. Stray mark there. Erase that. Okay. So let's stick with Learning Target 5 here. Let's get back together here. All right. Let's do what method 1 would say, which is add the fractions and then cross multiply. So the common denominator is 6. So I would multiply this fraction by 2 over 2 and this one by 3 over 3. So I'd get 2x minus 6, and I'd get 3x here equals 4. And when we add the fractions, we get 5x minus 6, all divided by 6, equals 4. Which 4 is a fraction, it's 4 over 1. So now that we have one fraction equals another fraction, this is where you can cross multiply. And when you cross multiply, you get 5x minus 6 times 1. So 5x minus 6 equals 6 times 4 equals 24. And we add our 6, divide by 5, and x is 6. So like I said before, this may seem like it's not too complicated and it's pretty fast and easy. It gets harder when the denominators are binomials and trinomials, so it's the less recommended method, okay? Over here is the method I would recommend. Method 2 involves getting rid of the fractions in one step. You can multiply by the LCD 6 that we already found, the least common denominator. Multiply by 6, change the pen here. Multiply by 6 and we will get rid of the fractions in the first step. So I usually don't show this, but I'll show it as we're doing the first problem. When you distribute 6 times the first fraction, it's 6 times x minus 3 over 3. And when you, remember, you're multiplying by 6 over 1, so it won't change the 3. And when you multiply 6 over 1 times x over 2, it becomes 6x over 2. And then to keep the balance, you multiply the 4 on the right side of the equation by 6 and get 24. And just like that, the fractions reduce to 2 over 1 and 3 over 1, which means the fractions are gone. It's 2 times x minus 3 plus 3x equals 24. You'll be a fan of this method, multiplying by the LCD to get rid of the fractions. If you practice it, I promise, it's definitely less steps, less intensive than method 1. So we finish it by distributing the 2, combining like terms. We add the 2x and the 3x, and we get 5x minus 6 equals 24, and add the 6, divide by 5, and once again, get x equals 6. Here's the steps for Learning Target 5. We can cross multiply if there's only one fraction on each side, etc., etc. You'll notice that I've crossed out method 1 because I don't really recommend it and want to focus on method 2. And then we're just going to do a few more examples using these steps on the next page. Now Number 3 and number 4 and number 6, if you look at all those, 3, 4, and 6, it's one fraction equals one fraction. So step 1 says cross multiply. And when we do, we get 6x, and 3 times x plus 1, distribute the 3. We get 6x equals 3x plus 3, subtract the 3x, divide by 3, and x is 1. You need to check the answer and make sure it works. 3 over 1, 6 over 1 plus 1. Yep, that works. Number 4, we cross multiply and we get x plus 1 times x equals 1 times 6 equals 6. And when we distribute, we get x squared plus x equals 6. We get a quadratic. So we subtract our 6. Whoops, x squared. Let me erase that. We subtract our 6 and we get x squared plus x. X squared plus x minus 6 equals 0. And then we factor that quadratic to x plus 3, x minus 2 equals 0. And the solutions are x equals negative 3 and x equals 2. So let's check those real quick, at least in our head. If I check the negative 3, it will say 1 over negative 2 equals negative 3 over 6. So 1 over negative 2 equals negative 3 over 6. Yeah, negative 1/2 equals negative 1/2. Check the 2. 1 over 3 equals 2 over 6. Yep, they both work. The example 6 I'll leave to you to try. You will end up getting answers. Let's see. Well, no, let's go ahead and do that one. Cross multiply x times x minus 1 equals 3 times 4 equals 12. You get x squared minus x equals 12. Subtract the 12. So we got x squared minus x, hard to see, minus x minus 12. That factors to x minus 4, x plus 3. And we get answers of x equals 4 and x equals negative 3. And if you plug them both in, they both work. That leaves us with 5 and 7 and 8. Now 8 I'm not going to actually work because it can be found in your green book on page 595. So it's kind of a long problem. It's definitely worth the read. So open up the green book, look at this page, check it out. But now on number 5 and 7, I'm going to use the strategy of getting rid of the fraction so that we don't have fractions, which is method 2, multiply by the LCD. So the LCD of number 5 would be 20. I'm going to multiply both sides by 20. And when we do, 20 times x minus 5 over 5, we distribute the 20. We get 20x over 4, and we get 8 times 20, 160. The fractions go away. This fraction, 20 over 5, becomes 4 times x minus 5. This fraction, 20 over 4, 20x over 4, becomes 5x, and it equals 160. We now have no more fractions, so let's distribute combine like terms and see what happens. When you distribute the 4, you get 4x minus 20 plus 5x equals 160. So I'll add the 4x and the 5x and get 9x. I'll go ahead and add the 20 to the right side of the equation, get 180. Divide by 9 and get 20. Might want to plug it in to check. But 20 minus 5 is 15 divided by 5, that's 3. Plus 20 divided by 4 is 5. So 3 plus 5, yep, gives us 8. So it works. Number 7, be careful. Number 7, that denominator 2 over 1, that denominator y minus 2, that denominator 6, the common denominator is 6 times y minus 2. So I'm going to multiply everything by 6 minus y, or 6 times y minus 2 and solve that. Or, because that's a plus 2, I can literally just subtract 2 to the right side and then have one fraction equals one fraction and cross multiply. So it's really a choice here. And when I think about those two choices, the easier of the two is going to be subtract that 2 instead of multiplying by the LCD. So this is one of the rare instances where method 1 actually helps. So I'm going to subtract that 2. So I'm not going to multiply by the LCD. Change my mind. I'm going to subtract the 2 and get 5 over y minus 2 equals 17 over 6 minus 2. For those that aren't really good with fractions, you might want to grab your calculator. See if it'll let me grab that. And then just take your parentheses, 17 over, what was the problem? 17 over 6. And subtract 2. And then hit math, enter, enter. And it gives you 5 over 6. So we end up with the fraction 5 over 6 once we subtract that 2 to the right side. Then we can cross multiply and get 5 times y minus 2 equals 5 times 6, 30. Distribute, combine like terms. Let's see, we got 5y minus 10 equals 30, no like terms. So add the 10, divide by 5, and y is 8. You definitely need to take a look at page 595, the Green Book, problem number 8. I'm actually pulling that up myself right now to take a look at it, because if memory serves me right, one of those is an answer that doesn't work. So page 595, example. Yes, when you look at the example in the book, they're going to multiply by the LCD and get rid of all the fractions, and they end up with the answers -5 and 1, but when they plug them back in, the -5 doesn't work. So -5 ends up being extraneous, so the only answer to number 8 is x equals +1. So again, all that works in your Green Book, and you can take a look at it yourself.